But what we are going to do is continue with fractions today, and we're going to do a different type of fraction, and this type of fraction is called the decimal, right? And so a decimal is a type of fraction, and this is where you have to write your notes, right? And you can see that we have an example of a decimal over here. A decimal often involves the whole number part, and then there is a point, and then there is the decimal or the fraction part. So the part after the point represents the fraction, right? And you can see this diagram here shows the placement values. So the whole number, you can see we have the ones, the tens, the hundreds, and the thousands. And this is just a little primary school review. But for the decimal part, we have the tenths, the hundredths, the thousandths, and the tens of thousandths, right? And there is a difference. And so we will see the difference later on in the class. If you don't understand this, we will talk about more about this just now. Okay. There are two types of decimals, right? Or two types of decimal. I guess that is correct, yeah? The terminating or non-repeating decimal, that is just the most exact decimal, 0.5. It doesn't repeat or recur or anything like that. And then there is number two, the repeating or recurring decimal, and that is 0.3333333 blah blah blah. It could go to infinity sometimes. Yeah, and of course a decimal like this means that we could never know the true value of it. We could never know exactly what it is because it goes to infinity. It never stops. Yeah, so we have the repeating, recurring decimal, we have the non-repeating decimal. Let me hear some donuts and then we're moving on. It's notes time today, so today expect to give Merrell donuts. I have one donut. This is an example of a terminating decimal or a non-repeating decimal. For example, a half could be expressed as a decimal 0.5. So 0.5 is a half. How do we go from a half to 0.5? How do we convert from a fraction to a decimal? We'll talk about that just now. Then we have recurring decimals. So a third is 0.3333333 to infinity. It recurs to infinity, right? So this is the reason why we prefer fractions in mathematics. We prefer, and you can even write that down. Why are you lagging? Why are you lagging? Prefer fractions in maths. We prefer fractions. Oh, come on. Come on. And I'm actually recording today's classes, so I guess that is why it's lagging. Right? So we prefer fractions simply because 1/3 is a more exact answer than 0.3333333. We could never know exactly what this is, but you do know exactly what a 1/3 of a pizza is. Yeah? So it is, a fraction is always the more exact answer. Examples of recurring decimals. We often use this dot on the top of the number to show that a decimal is recurring. So 0.33333 could just be written as 0.3 and the dot says recurring. Notice we have 0.57. The dot is on top of the 7, so the 7 is what is recurring. Notice I have 0.25. We have two dots on top of the 2 and the 5, so both the 2 and the 5 are recurring. Notice I have 0.312 with the dots separated from the 3 to the 2. That means that anything between the dots will be recurring. 312, 312, 312. Nice. And we have a little bit of homework here, and the homework is to write down the decimal form for pi. And some of you all might not know what pi is, but you will see it on your calculator. And I'm not going to tell you what pi is yet, not yet anyway, right? But you can try to write down the decimal form for pi, and that is your homework, and we will talk about that next class, right? Anybody have any questions on this? Decimal places, we're talking about rounding up and rounding down. So this is just your basic review here. We're talking about, if I have this decimal, 0.3849 to 3 decimal places, I have to look at 1, 2, 3. So it's up to here I want, right? But do we round up or do we round down? We have to look at the number after, right? So 0.384 is up to here I want. And then we have to look at the number after. And this number here is more than 5. Oh, come on. So therefore, we round. Oh, come on. We round up. Yeah, let me try something. I just want to try something and see if it'll stop lagging. Your screen share is loading. All right. So you all seeing the screen, right? All right, nice. So this is easy peasy stuff here. So you round up. So therefore you're going to get, this is equal to 0.385. That's what it means to round up, right? 3 decimal places. This one here is the 4 decimal places, right? So we see it's 21.1234 decimal places, right? So 21.2463 is up to there we want, but we have to check the number after, which is 2. And if that number is less than 5, we do round down. Well, round down doesn't mean to actually go down. Rounding down means you stay where you are. So that is 21.2463. So you actually stay where you are. You do not go lower. So if the number after is more than 5, you round up. If the number after is less than 5, you stay where you are. Any questions? All right, I'm assuming everybody done. Anybody still writing? Right, when it comes to moving the decimal point now, we can move the decimal point by either multiplying by tens. Notice the S. Or dividing by tens. Notice the S. For example, if we are multiplying by tens, the decimal point will move this way. If we are dividing by tens, the decimal point will move this way. So let's see, right? We have the number 0.5 multiplied by 10. So that decimal number is going to move. 10 is 1 0. If I have 1 0, I'm going to move 1 space this way. So the answer is 5. Or we could say 5.0. As you can see, if we have a whole number, it is understood that the decimal comes after the whole number. That's an important point there. If you didn't know that, write it down. Notice here I have 0.27 multiplied by 100. You look at the amount of zeros, 2 zeros, so you move 2 spaces this direction, and my decimal point will end up 27.0. Notice I have 3 zeros here. So 0.3 moving 3 spaces, 1, 2, 3, right? Means I will have 3 and 2 extra spaces. I add 2 zeros there, and my point will be here. Yeah. When we are dividing, we carry the point in the opposite direction. So notice that 38 divided by 10, 38, oh crap, 38 is a whole number, the point is after the whole number. And when you're dividing by 10, the point will go this way. And it goes 1 0, so it'll go one space. The answer is 3.8. Over here, you see I have 243. The point for a whole number, the point is always after. And you're dividing by 100. That means 2 zeros. So the point is going to move 2 spaces. I will end up with 2.43. If we look at this here, I have the number 3. Remember, any whole number, the point will come right after. Yeah, and that's divided by 1,000. So that point will go 3 spaces. 1, 2, oh come on with that lag, 3, and then the point will end up here. So I will get 0.2 spaces, 0, 0, 0, 0, 3. So this is how we move the decimal point, by multiplying or dividing by tens. Creepy, 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 going easy. Let's go. Converting fractions to decimals. We know that a half is equal to 0.5, but how do we go from a half to 0.5? Well, what we have to do is we have to do the dreaded long division, right? So what you have to remember is this is 1, and that 1 is being divided by 2. Anybody remember how to do long division? Sarah, you all remember? So how do I divide 1 by 2?
2 into well, you can't.
Right. So how many 2's are there inside of 1? It have none. So there you put your 0. Alright, and once you reach a 0, you have nothing to do. So now you put the point, and you have to put a point here too. And now we put as yes, very good. We add the 0 there, and now we have to treat this like a 10, right? So how many 2's are there in 10? How many times 2 into 10? 5. So now we have the 5. 5 times 2. Do I put the 10 over here?
No.
No. Where do I put the 10?
No, so you just put it under the 1.0.
Under the 1.0. But how though? How is it? Why isn't it 0.10? And the 5 is on this side of the point. So why isn't it this? Because we don't want to get confused.
5 is 1 decimal place.
Very good, very good.
0.10, that will be 2.
Right. So we have a note here now. Right? And the note is that exactly what Sarah was saying. If we have 0.5 multiplied by 2, all you do is multiply, and we'll see that when we multiply in fractions just now. You multiply by like normal. 5 2's are 10. When you multiply in decimals, I mean. And then you just count the amount of decimal spaces in the whole question. So if this is 1 decimal space, well then you put from here 1 decimal space, you'll get 1.0. If we had, say, 0.05 times 2, same thing. 5 2's are 10, but then you count the amount of decimal spaces. 1, 2, so from here you go 1, 2, and you'll get 0.10 or 0.1. Right? And that's our next point to make, is that if you have a 0 after a decimal place, you don't need to put that 0. Right? If I have 0.5 multiplied by 0.2, I just do the same thing, multiply 5 2's are 10, and then count the amount of decimal spaces in the question. So this is 1 space, and this is 2 space, so I'll go 1, 2, and I will get my decimal point here. So this Oh, come on with the lagging, yo. This is also 0.1. It's lagging right now because I'm recording the class and the Zoom is on share screen. So all of that seems to be a little bit too much, but we'll see if we can fight it through. So yes, so 5.5 multiplied by 2, we'll have to put the point there, and so we will get 0. And so this is how we convert fractions to decimals. Anybody done it? All right, so let's just do it quick. So number 1. Oh, come on with the lag breads. All right, number 1a, we have 12 over 11. So that is 12 being divided by 11, right? So how many 11s are there in 12?
1.
Very good, 1. So 1 11 is 11. And then I do the minus. 12 minus 11 is I have 1, right? So I have 1 remainder. How many 11s are there in 1?
So you can see that?
How many 11s are there in 1?
0.
0, right? So now I have to put the point, right? And I have to put a point here. There are 0 11s in 1. So I have to add the 0 here. And then what we are saying is, now we say how much you, no, sorry. I think I did that wrong. Yeah. Oops. Yeah, I'm totally messing this up. All right. So there's 1 times 11 is 11. So 12 minus 11 will give me 1. And, well, 11 can't go into 1. So this is where I will have to put the point and add the 0. And this is where I will have to put the point here, right? 11, now we ask ourselves, well, 11 into 10. Can 11 go into 10? No, it cannot. So we add a 0 here, right? Oh, come on with the lag, bro. And then we had to add another 0 here, and now we ask ourselves, well, can 11 go into 100? How much times can 11 go into 100?
9.
9 times. So when we add the 9 now, is 9 times 11 is 99. Remember, this is 2 decimal spaces. So we'll have the point, you have to keep the point in line, and we have the 2 decimal spaces for 99 day. All right, so 0.99. And we'll have 0.01. And now it goes on, so we could see that, well, all right, so how many 11s are in 1? Well, no, so we had to add a 0, right? And how many 11s now are in 10? So there is no 11s in 10. So 0 11s in 10. So we had to add our next 0 here. And then how many 11s are there in 100? We get back a 9. And it's just a repeating thing. And we could see that no matter how much we do this, it's just going to keep repeating. Just now. 9 times 11. This 9 times 11 is 99, and the 99 will be 1, 2, 3, 4 decimal spaces. So the 99 is going to be over here, 4 decimal spaces, and now we'll get 0.0001. Right? And this will keep recurring, so you can actually put a dot by the 9 and a dot by this 9 to show that it will just keep going. 0.909090990. Actually, if you want to be more exact, a better thing to do is to put the dot over here. So 90909090, and you can put the 9 here if you want. So 90909090 going down the line. Anybody have any questions? When last will they do long division?
Listen,
Uh-huh.
I have a question.
Yes, yes.
And so you see for number two, right? We have like 32 divided by 12, and it had the answer number, I think, which is 2.66666, right?
Mm-hmm.
But at the ending up of that number, that decimal, the last number was 7, right?
Right.
Would you consider that decimal fraction a recurring decimal?
No, it will be it will not be. So 32, let me just punch it in the calculator, divided by 12. What she's saying there is 0.666666667. But that's 7 though. That is at the end of the calculator, right? We don't know if it have any numbers after the 7. Yeah. But no, that will not be a recurring. That will be a even though it's just a long decimal place, but it does have a certain amount of spaces. It will not be recurring, right? And when we do the long division for it, so let's do 2a. When we do the long division for it, 32 being divided by 12, come with our lag again. That implies that I have 32 being divided by 12. And well, 12 into 32 is 2. 12 twos are 24. So 32 minus 24 is 8. Crap. Hate this lab board, right? And well, we can see 12 can't go into 8. So we put the dot and we add the 0. And we'll have to put a dot there as well. And then we have to say, well, all right, can 12 go into 80? Well, 6 times 12 is 72. That's as close as we'll get to 80. So we'll put the 6 there. 6 times 12 is 72. So we'll get 7.2. And the dots will remain aligned right through. So 80 minus 72 is 0.8. Right? And then you could see that, well, 12 can't go into 8, so we had to add a next 0, right? And so can 12 go into 80? Yes, we'll have 6 again. So 6 12s are 72 again, 0.72. Now this is very interesting because you can see that this thing is just going to be repeating, right? Because when I minus this now, I'll get 0.08. And now 0.08, well, I'll have to add a 0. All right, 12 can't go into 8, so I'll have to add a 0. Can 12 go into 80? Yes. 6 times. And now I'll get 0.072. But look at that, Kyla. Do you think that this ever going to reach the 7?
No, not at that rate.
Not at this rate, right? This never going to reach the 7. So at this point in time, because you're noticing here that if I do this minus, I will get back 0.008. I'll have to add the 0, which will give me back 80. And then I had to go back with 6 to get 72, which will give me back 8. You know what I mean? So I don't know how the calculator get a 7 on the end, honestly. I don't know if maybe the calculator was rounding it, or maybe if we actually do it for that length of time, if we will actually get the 7 on the end, you think? I don't see how, right? I don't see how. So we could just call this, 2.6 recurring. All right, well, we skipped number 1b because of Kyla, so let me just do it now. Number 1b. 38, sorry? Somebody have a question? Last chance, all right. 38 divided by 100, well, we just talked about when you're dividing by tens. It's just a matter of this is the point on this side, and I'm going to move the point in this direction 2 spaces. 1, 2. So I'll get 0.3 3, 8.
So how come you get fell up along the vision?
Me? Yeah, I dreadfully fell up along the vision. How you mean, right? No, we just skipped this one here. Oh, you wanted to do the long division way or what?
No, I could.
You sure? We can do it, you know, right? And
Also, we good.
but you could see how I did this before now, dividing by tens, right? So right, so we have 2b. So 2b there is 15 divided by 2. Oh, that is interesting. Long division there. Let's see what we'll get. So we have 15 divided by 2. Well, I know 7 times 2 is 14, and I'll just have 1 remaining. So 2 could go into 1. No, I'll put the point and I'll add the 0. I had to put the point there too. 2 could go into 10. Well, 5. 5 times 2 is that. And finally, we get something that's looking a little nicer. I hope that all you're getting these answers, because I just buzzing it through real quick, because I know how you all love long division, right? What about 31 divided by 4? This is number 3a. So that is 31 being divided by 4. I think 7 4s are 28, 29, 30, 31, 32, yeah. So 7 4s are 28. Let me know if I'm wrong. 29, 30, 31. 3 remaining. 4 can't go into 3. So I put the point and I add the 0. And I put the point there. Well, 7 4s are 28 again. That's the closest I'll get. So 28. We had a minus there. So we'll get 0.2. I'll have to add a 0. And 5 4s will give me 20. 0.20. And I'll get 0. Anybody have any questions? Because we could do more. Anybody want to do any more? Asia, you're cool with this, right?
Yes, I good.
All right, you're good. Anybody want to do any more? We have older students in the group. You know, them adults and thing do long division in 40 years, right? So anybody wants to do any more? Because we do have a couple more here. All right. So now we're talking about going the other way now, right? Converting each decimal to its simplest fraction. How do we convert a decimal to a fraction? It's actually very easy. Let's take number 1. So this is a new topic from decimal. Oh, come on with this lag, yo. To fractions. Right? And number 1, we have 0.6. If you want to convert this to a fraction, you put your vinculum. Where you have the point, you put a 1. And then for every decimal space after, you put a 0. This is where this whole 10th, 100th thing came from. Because you could see that 1 decimal space is 1/10. So this is 6/10 is really the answer here. And of course, we could reduce it. 3 2s are 6, 5 2s are 10. So when we reduce it, we get 3 over 5. Let me try number 34 here. Sorry, number 13. 0.34. You add your vinculum, you put the 1 where the decimal is, you add 2 zeros, and this is really 34 over 100, which really boils down to be, can that be reduced? Yes, it can be reduced because they're both even. It boils down to be 17 over 50. And that's pretty much it, man. Let me just do this one here, number 17. 0.325. So 0.325, you draw your vinculum, you have the one where the point is, and we have 3 decimal spaces, so we put 3 zeros. This is 325 over 1,000, which will work out to be 325 fraction button 1,000. It works out to be 13 over 40. Anybody have any questions? As I say, this stuff is easy breezy and we're just breezing it through. Any questions at all? Would you guys like to, because as you can see, I have a whole bunch of questions here. Does anybody think that they want to try a couple of examples here, or do you just want to move on? What do you think? All right, well, seeing that everybody have, you want to try number 34. All right, interesting, right? Because number 34 have a whole number. A couple of them have whole numbers. So very good for you to see that. So what we have here, we have number 34, 5.391. Well, when it comes to the whole number, we're not doing anything with the whole number. The whole number will remain a whole number. We're just dealing with the fraction part. So we put the 1,000. And that will be 5 and 391 over 1,000. And of course, we could reduce the 391. Can we reduce the 391 over 1,000? 391 fraction button 1,000 equals, nope, it cannot be reduced. So this is the actual answer, as ugly as that looks. Yeah. But there is another one here. We could see we have 2.63. 2.63. You add your vinculum. This is over 100. So what do we have? 2 and 63 over 100. Can that be reduced? 63 over 100 cannot be reduced. So that'll remain the answer. Alright, so this was 34. This was 27. And now we're just going to do one more. Let's try number 30. I want to do one that can reduce, right? So you have 7.28. So you just draw the line. You have the 1 there, the 0, the 0. So you have 7 and 28 over 100. So what I will try to do is just reduce the 28 over 100 in my calculator. 28 fraction 100 equals, so what we get is 7, and then the fraction turns out to be 7 over 25. Any questions? Easy peasy class today, eh? Well, we can see how easy it is. We go see, and you know how, imagine what Spotlight Challenge for decimals does look like. Right, adding decimals. To add decimals, all you do is make sure that the points are lined up. You fill in any zeros just to make sure that all of the place values are lined up. And then you add as normal. 0 and 5 is 5. 0 plus 2 is 2. 7 and 8, or 7 and 7 is 14, so 7 and 8 will be 15. Now carry the 1. 4 and 3 is 7 and 1 is 8. Of course, the point is over here. And then 1 plus 0 is 1. 18.525. Do these two real quick. Do not use a calculator. Just add it normal. And we'll see. The reason why I'm telling you don't use a calculator, add it normal, is please remember the mathematics paper 1, which actually they wrote at 9 o'clock this morning, was the maths paper 1 exam, was 9 o'clock this morning, right? That paper 1, you're not allowed to use a calculator. So we do have to have at least one special class talking about mental mathematics techniques. But we can see, right? So with this one, You just add the 0 here just to fill up all of the spaces. Is an addition. So 0 and 2 is 0. 0 and 2 is 2, sorry. 6 plus 1 is 7. 9, 10, 11. You carry the 1. You have the point here. 6 and 5 is 11, and 1 is 12. Yes, excellent job, Terry. All right. And then we have the 0 here. So for this one, 9 and 1 is 10. Carry the 1. 8, 9, 10, 11, and 1 is 12. Right. Sorry, did I make a mistake?
No.
Okay. All right, just making sure. And then 9, 10, 11, and 1 is another 12. Carry the 1. And then 4 plus 1 is 5. Easy peasy. Anybody still writing? Yeah, so I just making sure I do over all of these basic things, even though they're from SCA, they do play a very important role, especially with the first 10 questions in your paper 1 is this kind of thing. And then the question 1 in your paper 2 is this kind of thing. Subtracting fractions now. And then, of course, we're doing adding, subtracting, multiplying, and dividing. And we're done. Right? Subtracting, decimals, it's actually the same thing. You fill in your zeros, and then you subtract as normal. 2 minus 0 is 2. 8 minus 0 is 8. 9 minus 3 is 6. And then you have the point. 5 minus 4 is 1. That was an easy one. But then look here. We have this to fill in the zeros. And then we say, well, 0 minus 1, no. So we'll have to take 1 from here. So this will become 8, and this will become 10. All right, so we're doing it the same way. 10 minus 1 is 9. 8 minus 8 is 0. 0.3 minus 2 is 1. And then I have the 4 here. Over here, we had to add the 0. And we can see 0 minus 8. No, we can't do that. We had to take 1 from here. So 10 minus 8 is 2. 3 minus 2 is 1. 2 minus 3. Well, we can't do that. We had to take 1 from here. So this is 2. And then this will be 12. Yeah? Did I make a mistake?
So I don't know what. I don't know if it was a flip or something.
What?
Like the 2 can minus the 5.
Of course the 2 could minus the 5. We are in big people school now. We in big people school now. So yeah, we're not in SCA anymore. Of course in big people school 2 could minus 5. We will see, right? So 12 minus 3 is how much? 9, 10, 11, 12. Yeah, that's 9. Then we have the point. Let me hear how 2 could minus 5 now. Let me hear you.
Positive and negative.
That's right. That's what we're talking about. So a positive 2 minus a 5, when the signs are different, you find the difference and you keep the sign of the larger number. Because remember, that would be 2 minus 5. So the 5 is the negative here, right? You see how all of them rules, eh? Them rules. Nice. Any questions? All right. Multiplying decimals, as we were talking about, if you have 4.2 multiplied by 5.8, how do we multiply these things? And I'm talking about without a calculator. Eh? Without a calculator, right? So we're talking about long multiplication now. 4.2.
Just multiply it normal and count the decimal place.
Exactly. So 4.2 multiplied by 5.8, you just multiply it normal. 42 multiplied by 58. Right? How do we do long multiplication? How you just do that again?
So multiply 5 by the 2.
All right, so first we're going to multiply, first we're going to multiply the 42 by the 5 first. All right, so that means I had to have a 0 here, and?
Yeah, but that's supposed to come after.
All right, so 5 twos are 10, and I what do I carry the 1?
I can't remember.
And
Sister.
yeah, Sarah?
So, and it's kind of different way to like arrange the numbers. You could put 42 multiplied, and you could put the 5 under the 2, and then put the 8.
Oh, is that's for multiply, right? 58. You mean like this?
Yes, sir.
Right, multiply.
Yes, sir. And then it'll be easier to multiply.
All right, so the
And
40.
then you just multiply
All right,
by 2.
5.
4 by 5.
But isn't it the same thing though? Because you're still multiplying the 42 by the 5s, right?
But so for some reason, when you have it, like how we have it with the 4.2 multiplied by the 5.8, it'll be more confusing to multiply.
All right, so walk me through this, right? What you're saying is I'm multiplying the 42 by the 5 first, right? Yeah.
Yes.
So 5 twos are 10, right? What are doing with the 1? I'm carrying the 1. Yeah. And then 5 fours are 20 and 1 is 21. That is what I know. And then I had to add a 0 here.
Yes, sir.
Right. Yeah, because for this.
42 multiplied by the 8.
And then I do 42 multiplied by 8. So 8 twos are 16. So you see why I add the 0 there, right? 16, 33. Terry, I'm causing some trouble here now. So the final answer. Like a boss, Terry. Wow. So Terry Ann, what Terry Ann saying is that she is bored and she would like to get on with class quickly and stop wasting time with this easy stuff, and yeah, I feel that's what she's saying, right? Yes, very good, Anaya, right? But where did this method come from?
I don't know, but it's really work easier.
It is really, but where did this method come from? Did you know what? Well, look at what we did. Look at what we did. We multiplied 42 by 5, and then we added it to 42 by 8, and in fact, we didn't multiply 42 by 5. We multiplied 42 by 50 because we.
50.
Right. So what we actually just did, this long multiplication, actually came from the distributive law. What we did was 42 multiplied by 50 plus 8. That is what we just did. So 42 multiplied by 50 is 2100, and then plus 42 multiplied by 8 is 336. Now, for those of you who don't remember the distributive law, don't worry, we will do it soon. But especially for my younger students who would have remembered it, this actually came from the distributive law, this method here. So something interesting to note. Anybody doing anything? Still writing? Yes? No? Zip? Oh, look, we have some multiplying decimals there. Would you like to do it? How about we just do 2? All right, how about we just do 2 and then call that George? Right. Huh?
Yes, sir.
All right, let's just do these 2 here. How about that? All right, so take 2 minutes and do those 2. All right, so the first one here, we could really treat it as 95 times 26, right? So 95 times the 2. So 5 twos are 10.
190.
And 9 twos are 18, and 1 is 19. And then I have to add the 0 here. And now I'll go 95 times 6. So 6 5s are 30. And 6 9s are what, 54? 55, 57. 57. 2470. And it's 2 decimal spaces, so it's going to be here, right? Right, lovely. What about this one now? 70. Well, I can see that this will be 73 multiplied by 10, which will end up being 730. And then
True and good.
And check this piece of thing, right? 73 multiplied by 10 is 730. So 73 multiplied by 9 will be 73 multiplied by 10 minus 7.3. Anyways, let me not do that and confuse people. So 9 threes are what? 27? All right. And 7 nines are
63.
55.
That's 6.
7 nines are 63, 65, right, yes. And then when you add this, you get 7, 8. All right, and then we add. All right. Anybody want to do any more? Anybody want to do any more? All right. Well, Terry Ann in a mood here. All right, Terry Ann. Let me do one last one. Terry Ann, you choose one for me to do. All right, let me do that one. 3.7 times 9.5. And you see why, Sarah, I wrote it the way I wrote it initially. Because when you're talking about decimals, the decimals just had a line up, right? So shifting it one space, this kind of mess things up, right? But just remember, it's really about the distributive law. You're multiplying 37 by 90, and then you're multiplying 37 by 5, right? So 7 nines are what? 63. And 9 threes are 27, and 27 plus 6 is 33. And then I have add a 0 there. And now I go 7 fives are 35. And then 5 threes are 15, 16, 17, 18. So I have 5, 8, 9, 10, 11. So 11. 3 and 1 is 4, and 1 is 5. And then 2 decimal places. Lovely. Very good. Anybody have any questions? All right. Yeah, you have a question? Yes? No? All right. Let me see if we can get out of here by 7:30. Yeah, you have a question? You say yes? No? All right. Divide and fractions. Long division again. But we're going to do it a little different this time. When we have 0.45 divided by 0.9, what we want to do is we want to make the denominator a whole number. So to make the denominator a whole number, we will multiply by 10. Oh, come on, laggy. And we'll have to do the same, multiply by 10 on the top. So what we'll actually get is 0, not even 0. We'll actually get 4.5. 4.5 on the top divided by 9. And now we do the normal long division. 4.5 divided by 9.
0.5.
Right, so so you can't go into, you're right, so it's 0. And I don't know if you're using your calculators for this, but try not to, right? Yeah? All right, no problem, right? So yes, 0 into 9 is 0, so you put your point there, and then 5 nines are 45, and we're good to go. Lovely. Remember. No problem, sorry. I know others be going fast sometimes. We pretty much done there, you know. So we will have some time to go over any BODMAS or anything from previous classes that anybody wants. And we'll also have time to look at the Spotlight Challenge. Or we can leave the Spotlight Challenge for our next day if anybody actually wants to try it now. Right? But we go see, right? We go see how it goes.
You're done, sir.
Mm-hmm. Remember, when multiplying, always count the number of decimal places in a question to find your answer. This question here is a question that they love to bring in a maths paper 1. They just bring this question or questions like this pretty much every paper 1. So the question says, if 4.893 multiplied by 0.25 is equal to 1.22325, then what is 489.3 multiplied by 2.5? Anybody? No calculators, by the way. Eh? No calculator, because this is
122.325.
right. So all you do is write down the same number 1,22325, and then you just count the decimal spaces, man. 1, 2. So write it. So 1,223.25. We have our next one here. If 3.82 is equal to 0.054, no, if 3.82 multiplied by 0.054 is equal to 0.20628, then what is 0.0382 multiplied by 5.4?
That would be 2.0628.
So I will just write down this answer here.
Yeah, the same thing.
Yeah, and I will just count 1, 2, 3, 4, 5 decimal places. 1, 2, 3, 4, 5. So yes, you will actually get back the same answer, and you can check it on your calculator. 0.20628.
So how is like so the both of them are the same, they just how the decimal just move it. Okay.
Yeah, exactly. Once they are the same number, so you look, this is a 382 and this is a 54. These are 382 and these are 54. So and you know when you multiplying decimals, you do like if you multiply the whole numbers and then you count the decimal spaces, right? But if we look at it, this is a small number. Well, this is the large number and this is a very small number, right? But look now, this became the large number and this became the very small number. But in each case, 1, 2, 3, 4, 5 decimal spaces here, and then in this question, 1, 2, 3, 4, 5 decimal spaces here. So both of them will give us the same answer. So don't teeth up your head. Yeah, it's actually nice and simple. Any questions? All right, well, guess what? I have some questions for y'all. No problem. So you guys have 2 minutes to do this. All right, guys. So 2 minutes up. Number 1. Anybody want to give me number 1 real fast?
563.19.
Thank you. 563.19. It's multiplied by 1,000. Multiply means you're moving in this direction. And so we move in 1, 2, 3 spaces because we have 3 zeros. Answer for number 2. Quick. Nobody? I guess we're staying here till 8 o'clock.
28 around.
Let me see. We had a multiply, so we're going in this direction. And 1, 2, 3, 4 zeros means we go in 1, 2, 3, and then 4. So that gives us 2810, 2,810. Yeah. Number 3. Anybody? Remember, the longer you take the answers, the longer we take to get out of here.
54.1.
Thank you very much. Asia is the only person who is interested in ending the class early, right? So thank you very much, Asia. So we have going in this direction because we are dividing. We move in 3 decimal spaces. 1, 2, 3. So the actual answer is 0 point, because the point will be here, and we got up as 0 here. 0, 5, 4, 2. Remember, when we divide in, we move in the decimal space this way. Answer for number 4.
4.825.
Thank you very much. Divide means we're going in this way. And we have 2 zeros here, so we move in 1, 2. So the answer is 4.8259. Oh, come on, lag. Stop it. All right. Oh, what about this one? No, this one is a piece of BODMAS. And I'd just like to remind you, when it comes to BODMAS, remember what I said about BODMAS, that multiplication glues numbers together. So these two are glued together. You could think of that as being one number. Division glues numbers together. So you could think about this as being one number. And addition and subtraction separates numbers. So these are 2 numbers here being subtracted. What is the first number? This number here.
0.529.
Careful, this is a multiply. Multiply means the decimal going this way.
52.7.
So it'll be, it'll be 52, right? The decimal going this way by 2 decimal places. 1, 2, so it's 52.97 minus in, and then this one, the decimal going this way. Yeah, by 3 spaces. So 1, so if we have 5.698 going this way by 3 spaces. 1, 2, 3. Stop it lagging. Oh God, this lag is really getting to me. The point will be here, so I'll have to put 2 zeros there. So 0.005698. And of course, I will expect you to use a calculator to minus this 52 point, because you'll never get, in a paper one, you'll never get something like this to do mentally, right? 97 minus 0.005698. It wouldn't be much at all, so the answer is 52.964302, and this is a terminating decimal, so it done there, nothing recurring. Same thing with BODMAS here. Multiplication glues numbers together, so these two are glued together, right? These two are glued. Oh, come on, lag. That lag is really testing my patience, yes? These two are glued together as well. So now this will be, is a multiply, so we move in this way by 1 space. So this will be 6 minus 5 plus, and then this is a divide, so it'll be moving 1, 2 spaces, so I'll get 0.07869. So we know 6 minus 5 is 1. 1 plus this will give me 1.07869. And then we have this one. This is the, oh God, these things are so ugly, man. Why did I give you guys such ugly questions? But I think you all get the point, right? This one here is a divide, so it's moving in this direction by 2 spaces. So 1, 2, so it'll be 0.0078. 0.0078 plus this is a multiply, so it moves in this direction 1 decimal space, 87.5, and well, you can add that using the calculator. Actually, you don't need a calculator. 87 is right before the point. You have the point, and then the 5 will come over here, and then I'll have the 0 and the 7 and the 8. Right? That one was easy to add. And then last, we have 1,000 divided by 10,000. So we have 1, 2, 3, 4 decimal spaces. So the point is here. We move in 1, 2, 3, 4. The point will end up here. So this is 0.1. Remember, this is a divide. So this is this lag is a divide. So this is glued together. And this is a multiply. This is glued together. So of course 30 multiplied by all of that means, well, you know you have 30. The point is over here. And so therefore we have to add 1, 2, 3, 4, 5. So the point is going to go this way. 1, just now, when it done lag. All right, 1, 2, 3, 4, 5. And the point will end up here. That is why you add 5 zeros. 1, 2, 3, 4, 5. So I'll end up getting 0.1 minus, what is this? 1, 2, 3, 4, 5, 6, 3 million. 0.1 minus 3 million, boy, I wonder what that is. 0.1 minus 3, 1, 2, 3, 4, 5, 6. I'm anxious to see this one. It'll be negative, so the answer is negative 2,999,999.9. All right, guys. So that is it for today. I do have some more questions here, but oh gosh, I think that you all get the point. Yeah? So anybody have any questions about decimals? Right? So as I say, we just cutting through the curriculum, right? The first 2 or 3 classes that we did here when it comes to basic arithmetic and fractions, those 2 classes are some of the most important classes in the entire curriculum. So like how Asiya says she's getting problems with BODMAS, I'm going to stay back with Asiya now and just go over BODMAS. And if anybody wants to stay back with us, feel free to stay back with us. And we can go over BODMAS. Sir, can you go to the part where it says remember, please? All right, I don't remember what part that is. I think that is this part, remember. Right? So, I will be staying back to just talk about BODMAS. But I do have a question before I let you guys go. Please raise your hand. How many people did the Spotlight Challenge? Let me see a raise of hands. 1, 2, 3, 4, 5. 5, 6 people did the Spotlight Challenge. Anybody else? Zafir, I see you applauding there. That is not a raise of hands. That is an applaud. 7 people did the Spotlight Challenge. Do you all want me to correct it now? Or should I give a little bit of time till Saturday for anybody else who wants to try it?
Time.
Time? You want to try it?
Yes.
All right, so this is the Spotlight Challenge here. Right, so I will give you guys until Saturday. On Saturday, that is it for decimals. We are going to be doing no more decimals. So on Saturday, we will be doing our percentages and ratios, and that will finish our study of fractions. So percentages and ratios, then we'll move on to the laws of indices and all of them kind of thing, and then we'll be hitting algebra by July, right?